so that we can go very quickly and cover some ground today. All right, so we are going to be looking at motion. We've already defined motion, so let's go straight to types of motion and some examples. Examples of types of motion. We have a translational motion. Translational, that is a straight line motion, right? Straight line motion. It's the same thing as linear motion. You can call it linear motion, or a curved motion, motion in a curved path. Translational motion is movement in a straight line or in a curved path. If it is movement in a straight line, we call it linear or collinear, depending on how many objects or bodies are moving. Okay, you can call it linear motion if it's a straight line motion. For example, a car moving on a road. Then you have a rotational motion. From the name rotation, that's when an object moves about an axis. When an object moves about an axis, that is rotational. E.g., spinning wheel, or a fan, like a spinning fan, a fan that is rotating, a ceiling fan that is working, is carrying out a rotational motion. Oscillatory or vibratory motion, that's a to and fro movement about a mean position. An example is the simple harmonic motion, right? Simple harmonic motion. That is pendulum and tuning fork. Then random motion. Motion with no definite path. When you say something is random, you are not specific. Motion with no definite path. You can't say it's linear, you can't say it's straight line, you can't say it's curved, you can't say it's rotational. It's just indefinite. And examples of should I say bodies or matter that undergoes such motion is gas. Gas is random in movement. It does not have any path. It can move through any direction. So that is random motion. Then circular motion. Motion along a circular path. Circular path, e.g., fan blades. Motion along a circular path. Circular, something continues to move in a circular form. The difference between this and rotational motion, anything can rotate. Okay, anything can rotate, and this one is about an axis. It has a fixed point. It has a fixed point. But when something is, it's not necessarily moving in a circular path, like it's not going round and round and round. Which object can I use as an example? Let's say a spinning wheel. A spinning wheel is moving in its axis, but it's also moving a car. Let's say the car tires now that are spinning is moving around about an axis, but it's moving the car. It's not moving the car in a circular form. It's not moving this car in a circular form, which means the wheel is just rotating. All it needs to do is to rotate. That's rotational. But if it is circular, it is moving in the circular path. The path is circular. For something to be moving in a circular path, that is circular motion. Okay, then force, of course, is the cause of motion, because while we were doing work, energy, and power, we said that work is done when force is applied on an object to move it across a perpendicular distance. So work is done when force is applied to move an object across a particular distance. The same thing with motion, all right? Just as Newton's first law of motion states that when a body is at rest or in uniform motion, uh, it remains or it continues in that position unless it is acted upon by an external force. So if a body is at rest, it's not in motion. For it to be in motion, it has to be acted upon by a force. So we can say force is the cause of motion. Force is the cause of motion. So force can be a pull or a push. Okay, to push something requires application of force. To pull it still requires an application of force. So force can be either a pull or a push. Okay, force can be a pull or a push. Now, push is force applied away from yourself. Force applied away from yourself. Pull, force applied towards yourself. When you draw something towards yourself, that is pull. When you push it away from yourself, okay, that is push as a form of force. You apply force to keep an object away from you, that is push. But to keep it, to bring it towards you, that is pull. Both of them are contact forces. Why are they contact forces? Because for you to do any of them, for you to push or pull, you must touch that object. You can't push an object without touching the object, except you are Merlin, you want to do magic. So for you to push an object, you must be in contact with that object. Either you are using your hands or your legs, whatever. For you to pull, the same thing. So you call such forces contact forces, because there are forces that are non-contact forces, okay? They are not contact forces. We'll look at them. Are they part of this? Example, just in case they are not here, let me just mention example, field forces. If you have heard of field forces like electrical force, magnetic force, field in physics. You have a gravitational field. Such forces, they don't need to be in contact with the object. They don't need to be in contact for them to exert their influence. Magnet does not need to be in contact with an object directly before it exerts an influence. All it needs is for the object to be around its magnetic field. Once a magnetic material is around the magnetic field of a magnet, that magnetic material will feel what we call magnetic force. That is a non-contact force. It doesn't have to touch it. It just needs to be around its magnetic field. The same thing with electrical, gravitational, just like that. Okay, those types of force are non-contact. Then contact force, the one you have to touch. Okay, so just keep that in mind. Then let me see if we can just start calculations immediately, so that we'll do something, we calculate, we do another, we calculate, we just keep going in that manner. Okay, now I would love to give you some formulas that, okay, I want you to write these formulas down before we start calculating. The formulas that we employ in this motion. Okay, you have equations of uniformly accelerated motion. Please write this down. I believe you have seen these equations before, so we are going to see how you employ them. Now, if you look at, as you're writing them down, I'll be explaining how you employ these equations. Please, you know the terms already. U is initial velocity, V is final velocity, A is acceleration, S is displacement or distance, as the case may be, or height. Yes, S can represent distance, displacement, or height. We call it height if it is a vertical motion. I've said that before. Vertical motion, that is from up to down, right? That is a vertical motion. If you throw something up or something is falling, that is a vertical motion. Such motion uses acceleration due to gravity in place of just acceleration. But if it is linear motion on the ground, a horizontal motion, you use ordinary acceleration. If it is vertical motion, you use acceleration due to gravity, that is g. So, and distance, the vertical distance is called height. Then if it is horizontal, you still regard it as distance. T stands for time. Now, what do I see before I apply, let's say, this first equation? What do I see in a question before I know, okay, I'm going to apply the first equation? Let me just simplify it for you now. You have to see the prominent parameters you are looking out for. You are looking out for velocity, acceleration, and time. Okay, I call it VAT. It enables me to remember very quickly. So when I see a question that mentions velocity, that mentions acceleration and time, I am going to apply V is equal to U plus AT. Whether it's a vertical motion or a horizontal motion, if it is vertical, your A is just going to be G. You change it to acceleration due to gravity, that is 9.8 or 10, depending on the value you are given in the question. Then to apply the second one, please be following what I'm saying. To apply the second one, you need to see distance or displacement or height. That's distance, which is your S. You need to see acceleration in the question. You need to see time, that is SAT. So if the three parameters you see in the question are distance or displacement, acceleration, and time, you employ this second one. Then this third one, you employ if what you are seeing in the question, if the three parameters you are seeing in the question are velocity, acceleration, and distance, that is VAS. Okay, velocity, distance. If the three things you are seeing in the question being mentioned, okay, the question is mentioning velocity, is mentioning acceleration, is mentioning distance, you employ V squared equals U squared plus 2AS. If it is acceleration, if it is a motion under gravity, that is a vertical motion now, your acceleration just change it to G. You change it to G. All right, please put that in mind. Put that in mind. And don't forget that your distance, if it is vertical, will be height. We will call it height. And if it is motion under gravity, any motion that is going against gravity, for example, if I throw an object up, it's going against gravity. So the acceleration due to gravity will be negative, it will be minus. But if it is coming down, if an object is falling, gravity is pushing it. Okay, so it's going in the direction of gravity. The acceleration due to gravity, G, will still be positive. But if it's going up against gravity, gravity is trying to push it back. So the acceleration due to gravity will be negative. Don't forget that also. All right, then which other formula do I want to give you now? Okay, let's look at projectile motion. Projectile motion. So I want to give you these formulas under projectile, and you see these three formulas usually are what you apply. You know, these UTME, they don't ask for too difficult stuffs. Okay, so they can ask you questions on, and we will see examples now. Time of flight. They can ask you to calculate the time of flight of a projectile. Projectile is an object or a body. Okay, let me even ask you to know whether you are still there. What's a projectile? What's a projectile?
So, um, I think maybe is when an object is being projected or thrown upward. I don't really have a definition, but
Okay, you thank you for your response. Yes, somebody else. What's a projectile?
So, an
Yes.
that is an object body launched into the air.
Okay. Okay, that's all.
Yes.
Okay. All right. You guys have some idea. Projectile is a body that undergoes a motion at a particular angle in the air, all right? It undergoes a motion at a particular angle, which means it's not usually a straight line motion. It's not exactly vertical motion, it's not horizontal. It travels, the object travels at a particular angle and returns to the ground. That is a projectile. Okay, so please, I want you to write these formulas down. That's time of flight is 2u sine theta over g, the time of flight of an object. Okay, let me add one again. Let me add one. So please write this down. U there still represents velocity, okay, the initial velocity of the object. Theta is the angle. Then g is acceleration due to gravity. Okay, so anywhere you see u, just know it's velocity. Theta is the angle at which the object travels. Then g is acceleration due to gravity. Then time taken to reach maximum height. Time taken to reach maximum height. I want to include that one. Is u sine theta. U sine theta. U sine theta over g. Now, if you look at this last formula that I've just written, time taken to reach maximum height is u sine theta over g. Compare it to time of flight. Time of flight is the time taken for an object to go up to reach its highest point and to return to the ground. So it's as if you have to double the time. You throw an object up, let's say it spends 3 seconds before returning. So which means in total, it's going to be 2 times 3. So the time is going to be double. That is why it's 2u. But if it's just the time it takes for the object to reach maximum height before returning, you don't need to multiply by 2. Please don't forget that. Time taken to reach maximum height is u sine theta over g. But if it is time to reach maximum height and return to the ground, is what we call time of flight. The total time of flight is 2u sine theta over g. Maximum height u square sine square theta over 2g. Range u square sine 2 theta. Please note those differences. Maximum height is u square sine square theta over 2g. Range is u square sine 2 theta over g. Students normally mix them up, maximum height and range. And you know that at an angle of 45 degrees, I believe you have done something like at an angle when theta is 45 degrees, if the object is traveling at 45 degrees, range is usually at maximum. Don't forget that range is at maximum when the object is traveling at 45 degrees. And if the object is traveling at 45 degrees, your range will look like this. Okay, let me write it here. At 45 degrees, don't forget I just said your range will be maximum at 45 degrees. Your range R will just be u square over g. U square over g. It will no longer be u square sine sine 2 theta. Why? Because 45, if theta is 45, 2 times 45 will give you 90, and sine 90 is 1. Sine 90 is 1, so it will have the angle will have no effect anymore on the range. So at 45 degrees, range is maximum. Don't forget, the formula will just be u square over g. The formula will just be u square over g. Don't forget that also. So projectile motion example, let's see examples of projectile motion. Okay, let's not start calculation now. Let's exhaust all the formulas that we'll be dealing with here. Let's look at another one. Impulse and momentum. Impulse and momentum. I want us to write that down so that when we start going now, everybody will follow why whatever we are writing is the way it is. So momentum P is equals to mv, that is a mass times velocity, okay? Mass times velocity, that's the formula for momentum. Mass times velocity. Impulse is change in momentum, all right? That is force times time is impulse. Change in momentum is impulse. Momentum is mass times velocity. Impulse is change in momentum, which is also force times time. So there are two formulas for impulse now. You can use force times time depending on what you are given in the question, or you can use change in momentum. Change in momentum is mv, which means there is a change in velocity. If there's a change in velocity, of course, there will be a change in momentum. mv minus mu. The mass remains the same. It's just the velocity that changes. The mass remains the same. It's just the velocity that changes. We'll see that very soon. Okay, so let's come back to motion now. Let's begin from collinear motion, motion in a straight line. So you have this. Let me expand so that you can see the question very well and pick out. Two cars A and B. Two cars A and B move along the same line. Car A moves at 10 meters per second and car B at 15 meters per second. You know, once you see meters per second, you are dealing with velocity. They have given you the initial velocities of these two cars now, 10 and 15 respectively. If car B starts 100 meters behind A, if car B starts 100 meters behind A, find the time B takes to catch A. Look at the person very well. It's a bit logical. Car A moves at 10 meters per second. So it means car A is slower than car B because car B is moving at 15 meters per second. But car B starts 10 meters behind car A. Find the time car B takes to catch A. So let's see it together now. This is what we call relative velocity. Relative velocity. I don't know if you have done something like that. Relative velocity is when you are comparing the velocities of two moving objects. Okay. Now, what you do first is to find the difference in their speed. That's the first thing you do. Okay. Find the difference in their speed. You know, you're having two objects moving on a straight line, but they have different speed. If it's just one object, you don't need to do this. I brought this first because it can look hard to some people. Find the difference between the velocities, the two velocities. Then you have gotten the distance, the difference, the distance you are given in the question. They say if car B starts 100 meters behind A, that is the starting distance. So the distance you are given is 100 meters. Find time. That's the question. Find time. You've already gotten their relative velocity, you've gotten distance, you've gotten time. And formula for time, or the relationship between distance, time, and velocity, if you still remember, you know that speed, for instance, or velocity, depending on whether it has direction or not, speed is equals to distance over time. I believe we all can still remember. This is just the first part of motion. Very simple. Distance over time. So speed is distance over time. So if speed is distance over time, it means time is going to be distance over speed. So and you have gotten your relative speed to be 5 meters per second. Distance is 100 meters. All you need to do is to just divide 100 over 5, you get 20 seconds. That is also when you are dealing with collinear. You know, I've said it before that you can have a linear motion where it's just one object that is moving on a straight line. You can have two objects moving on a straight line. When you have two objects moving on a straight line, that is a collinear motion. So you have to use their relative speed, except they are moving at the same speed. If they are not moving at the same speed, you have to do something like this. But if it's just one object, you don't need to. You just go straight to the formula. Speed is distance over time, and just make anyone you are looking for the subject. Okay, that is one. Okay, then just keep that in mind. Just keep that in mind first. Let me see. Okay, so I want you to also this one now is motion under gravity. I think I've said something about it, but I don't know whether you wrote anything under it. But this is when an object falls freely under gravity, acceleration becomes g, that's 9.8 meters per second square. When if it is an upward motion, your g is going to be negative. I have said that because in case you did not write it down, this is it. If it's an upward motion, your g becomes negative. So an example is this for motion under gravity. You know, I thought there's a relationship between these equations of uniformly accelerated motion and motion under gravity. The difference is that acceleration, normal acceleration or linear acceleration will become acceleration due to gravity if you are dealing with a vertical motion. So a stone is thrown vertically upward. A stone is thrown vertically upward with speed 20 meters per second. Find maximum height. It's just height they're asking you to reach. In this one, this is not projectile, because if it's projectile, the object will travel at an angle, at a particular angle. I've said it before. It is not directly vertical. It is not directly horizontal. Okay, so this one is not projectile. Just keep that in mind. So this stone has a speed of 20 meters per second. Find maximum height. If you look at it, you know, JAMB, if you have taken JAMB exam before, the test now, the CBT, you discover that there are times that they might not give you this 9.8 as the value for gravity, like it will not be written. To me, they expect you already know that acceleration due to gravity is 9.8, and it is important if you are dealing with a vertical motion. Don't forget that. In case they do not give you, don't be confused. Once you know the formula, okay, you look at the motion first. Is this a horizontal motion, the motion on the ground, or is a vertical motion, or is a projectile motion? That will tell you how to solve. Okay, so this one now is a vertical motion. So you just write the formula. You remember that to use to look at what you have. Speed has been given. That is the initial speed. It has been given to be 20 meters per second. Good. Which means if you, at maximum height, if you no longer have speed, which means the final velocity will be zero. At maximum height, final velocity is zero. When an object is at rest or is starting a motion from rest, please note all these statements that I'm making are very important. When an object is starting a motion from rest, initial velocity is zero, but it will have final velocity. If an object is going to rest, like it has been in motion, now is going to rest, is stopping, final velocity will be zero, but initial velocity will have a value. An object at a maximum height will have a final velocity of zero, an object thrown. So as it's going, once it reaches maximum height, it no longer has any velocity. That is why it will be returning. It has to come back. So because it can't go any further. The velocity is now zero. At maximum height, the velocity is zero. Please don't forget that. So which means I have a velocity mentioned in the question. You are given speed, that is u. Velocity is mentioned, height is mentioned, that's distance now. Then you already know, since it's a vertical motion, acceleration due to gravity will be there. So you have speed, you have distance or height, you have acceleration due to gravity. You are going to apply this third formula. V squared is equals to u squared plus 2as. But why is it minus here? I believe you already know why it's minus, because the object, the motion is going against gravity. It's upward. If I throw something up, it's going against gravity. So it's going to be negative.
Hello, Mr. Peter, are you there? Hello? Hello, Mr. Peter? Hello, Mr. Peter, are you there? If you are talking, we can't hear you.
Hello.
We can't hear you.
Can you hear me now?
Yes, I can hear you. We can hear you.
Wow. What about now? Okay. So where did you guys stop hearing me? I was explaining that question that I solved.
So he will reconnect. I think he's having a glitch. Please, let's be patient.
Okay, ma'am.
Hello, Vera, you're welcome. Vera, are you there?
Yes, ma. Good
You're
evening, ma.
welcome. Good evening.
I'm sorry.
Yeah. The class has been on. I think our teacher is having a glitch, a network glitch, so hopefully we'll join back soon.
All right, ma.
Okay.
All right, thank you.
Hello, please. Sorry for the interruption. Hello.
Welcome back.
Oh, okay. Thank you. My network is behaving somehow. It's doing drama. All right. Let's go back to where I was. I was explaining the motion under gravity that I saw, and I remember asking if everybody could understand what the solution is. Did we all see the solution? Did we all see it? That is this question. A stone is thrown vertically upward with speed 20 meters per second. Find maximum height. So I explained why this had to be the formula, because if you look at the question, speed is mentioned, one, height is mentioned, which is equivalent to distance, right? Two, then you know that since it's a vertical motion, you are going to have acceleration due to gravity. Three, so you have those three, which represent your velocity, acceleration, and distance. So we would have just used if it was a horizontal motion, our formula would have just been v square is equal to u square plus 2as. But this is a vertical motion. Instead of using s, I've told you before, you use h. You use h. Instead of using s, you use h. That is one. Instead of using a is for horizontal motion, motion on the ground. G is for vertical motion. So instead of using A, we use G. Now, why is this one negative? Why, if you look at the formula now, here, if you look at the formula, here is negative. Why? Because the motion is going against gravity, Okay. If it is coming down, if it's an object that is falling, for instance, if it is falling, it would have been plus, it would have been like this. But if it is going against gravity, it will be negative. Please don't forget that. Okay, and I explained that at maximum height, final velocity equals 0. I also said that an object starting a motion from rest does not have initial velocity because it's just starting from rest. The initial velocity is 0, but it's going to have a final velocity. Also, an object going to rest, that is stopping, it has been in motion and is stopping, will have 0 as the final velocity, but we have initial velocity. Please don't forget that. When you know these small things, you deal with motion in the simplest way. Okay, when an object is starting motion from rest, initial velocity is 0, but there will be final velocity. When an object is going to rest, the final velocity is 0, but there will be initial velocity. Don't forget that. When an object is thrown upward at maximum height, final velocity is 0. That is why the object has to return. It has to come back because there is no velocity anymore. It has exhausted all it has. All right. So, do we understand this particular solution we are looking at here?
Yes, sir.
Okay. So, which means if I give you another one now, you can solve it, right?
Yes, sir.
Okay. So, let me give you one. Let me give you a very simple question. an object moves I want to test whether you can identify units. So I've just explained this. So I want you to solve it now. An object moves from rest at 3 meters per second square for 5 seconds. Calculate the final velocity. Motion from rest. Motion from rest. Your time is counting. It's counting already.
Please.
Remember what I told you about those 3 equations of motion and when to apply them. So look at what you have in the question. You will know which of these 3 equations will fit in solving that question. Okay, so look at what you have in the question. So this is the question again. Should I solve?
Sir, 15
Okay, 15 what?
meter per second.
Okay,
Mine
yes.
15 meter per
15,
meter
your
per
own is
second.
15 too. Okay, Adamu, your own is 15 too, right?
Mm.
This call. Dima. Is Dima still with us? Okay, so let's continue. All right, I want to solve my question.
Please, is the network coming from me? Hello.
Oh, yeah, I'm not hearing.
Hello, guys. Is the bad network coming from me or him?
It's from you.
It's from him.
No.
Sorry, I am back. Sorry for that interruption. So I was solving my question. Okay, so I said if you look at the question, The question says that the object starts from rest, so your initial velocity is going to be 0. Then you have to calculate final velocity. Okay. You are given acceleration. Once you see meters per second square, that is acceleration, 3 meters per second square. Then if you look at it, you are given time also. Time is 5 seconds. So from there now, it's obvious that you are going to use V is equal to U plus AT. That's all. So your V, which is final velocity, is equal to 0 plus 3 times 5. So your answer is going to be 15. It's as simple as this, which means you guys are correct. That's 15 meters per second. Okay. So I did something like this just now. Okay, let me not even say it. Solve this for me. Just solve this. Just solve this for me. I don't want to tell you how to solve it because I've already done something like this. Solve it quickly. Are you true?
Sir, please wait.
Okay, I'm waiting.
Ten. 10 seconds.
Okay,
Away. No,
10
no, 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 no.
seconds.
Not
Check.
10, not
Okay,
10.
cross check.
15.
Are you solving
15.
it or you are guessing?
I'm not guessing, I'm solving.
Okay. So you are sure it's 15 now?
Yes, sir.
Okay, who else has solved his own?
10.
Wow, 10, 15.
No.
Okay, Another one, who else? So the person that got 15, can you explain to us how did you solve it? And the person that got 10, be ready to explain your own too. Go ahead. 15.
Sir,
Yes.
I used the velocity, which is 25, and the other velocity there, that is 25 minus 5 is 20.
Okay.
Then speed
Yes.
is equals to distance over time. You put your 20
Yes.
in distance equal to distance. Then the distance is 300 over the time, cross multiply. Then you divide.
Mm-hmm. Okay,
You
and
get
he
50.
gave you 15.
Mm-hmm.
So the person who got 10, please explain to us. I'm waiting. The person who got 10, explain. The person is not there. Have you cross-checked your work? You have seen whether there is a mistake, right? Or you
Yes,
still
sir.
want to maintain your... Okay, good. So just correct it. So you have to calculate for time. That is how long. How long always means time. How far always means distance. Don't forget, those phrases are important in physics. How long, time. How far, distance. Okay. So time is distance over speed. So which means time is equal to 300 over 20. So time is equal to 10 seconds. Very simple question. 10 seconds. All right. Let's
No,
move on.
sir. Sir, it's not 10.
Oh, 15. Thank you, Joe. Who got 10? The person has charmed me. Oh. 15 seconds. That's 300. Yeah, 30 over 2 will give you 15. Thank you. Then,
Excuse me.
yes.
Please, sir, can you go back to the formula? I just want to screenshot it. I came late.
Okay. Which formula now? We have many formulas here. Which one exactly?
The ones they've been using. If I couldn't solve it, I didn't get the formula.
Okay. Do you mean this one?
Yes.
We have this. We still have formulas for projectile. We have for impulse and momentum. So that's why I was asking which of the formulas.
If possible, you guide me to display it, then I can just screenshot. I will put it down later.
Okay. So have you taken the
Yes,
screenshot of this one?
yes, yes.
All right. Then let me give you projectile now. This is projectile. Time of flight, maximum height, range, and time taken to reach maximum height.
Thank you. I've taken that.
Okay, then impulse and momentum. Okay, this one just has two formulas. Okay, this one is an example. So the two formulas are what you are seeing there. Momentum is mass times velocity. Impulse is change in momentum, which is mv minus mu, or force times time.
Okay.
All right, is that okay now?
Yes, sir. Thank you so much,
Good,
sir.
you're welcome. So let's continue. Do you understand this last one we just solved?
No, I could not solve it because I don't know I don't know the formula. So I don't know.
Okay. When you watch the video, please just reach us if you still don't understand. Is that okay?
All right, sir.
On the Telegram group. All right. So let's do one or two examples on projectile now. Or should I still give you guys questions on motion, on linear motion now?
Yes, sir.
You like
Yes,
linear
sir.
motion?
No,
Okay,
sir.
Adamu,
It's success.
what did you say? Is Adamu still with us?
Yes, yes, yes.
Okay, this is a question now. Okay, are you seeing the question?
Yes, sir.
An object falls from a height with a speed of 10 meters per second. Calculate the height it falls from.
Sir,
You are done.
0.5. 0.5.
Wow, okay. Are you sure?
Yes, sir.
Which formula did you use?
V equals to U plus 2GH.
Good. Why didn't you put u square? Why didn't you say u square V square is equals to U square plus 2GH. There is a reason why you went straight to V square is equal to 2GH. Am I right?
Oh, sir, wait.
Hello, are you still there with us?
Yes, sir.
Okay, explain to us now. I want to know.
No, sir, wait, first. Ah, wait. Sorry, I omitted my squares.
Okay.
100 equals to 20 equals to 5.
Okay, answer is 5 now. Okay, others, please, what do you have? Let's verify. Okay, if you look at the question, let's not waste time. Our time is fast spent. If you look at the question, the question mentions height, which is unknown, or distance, height in place of distance, right? Then the question also mentions speed. No, this speed that is here now, is it initial or final speed? Who can tell me?
Final.
Final speed.
Okay. Why is it not initial? So what's now the value for initial?
0.
0.
Okay, because the object falls from rest. Good. 0. Then acceleration due to gravity, usually let's use 10 meters per second square. You know, I've said it's possible that you will not be given in a question. They may not mention it. I've seen it times and times again. So you just have to know, once you are dealing with a vertical motion, please, you have to know that acceleration due to gravity is involved. So since I have these parameters, I just go straight to my formula. V square equals U square plus 2GH. Why is it not minus? Why didn't I say U square minus 2GH?
Because it's not starting from
When does it become negative? When does it become negative?
when the object is at maximum.
Okay, see, it is negative when it is going against gravity. If the motion is upward against gravity, it will be negative. Okay, this plus will turn to negative. The acceleration due to gravity will be minus. Okay, but if it is downward, that is, it is under the influence of gravity now, it will be positive. So if you look at this one, if an object falls, of course, is coming under the influence of gravity. It's not going against gravity, so it will be positive. Do you understand that now?
Yes, sir.
Okay. So I have 100 is equal to 0. 0 square is 0, so 20h. So h, the height now is equal to 100 divided by 20. So you are going to have 5 meters. Very simple. Who doesn't understand this? Okay, so let's look at projectile, please. Our time is going. We should be able to solve 1 or 2 questions on the projectile. Okay, so this is a question. A ball is projected with velocity 20 meters per second at 30 degrees. Find time of flight, maximum height, and range. We've already written down their formulas. So formula for time of flight, that is 2u sine theta over g. 2u sine theta over g. So your velocity here is u, right? So let me write the parameter so that you know why solved like this. U is your velocity that is mentioned in the question. When you are dealing with projectile, please pay attention. U is the velocity mentioned in the question. Your theta is the angle given, that is 30 degrees. Your theta is the angle given. So you have these two. The acceleration due to gravity is a constant. The acceleration due to gravity is a constant. So in this case now, you can see that I used 9.8. If the question does not give you value for acceleration due to gravity, just use 10. So it makes it very easy for you to solve. So time of flight now is 2u sine theta over g. My u is 20, that is 2 times 20. 2 times 20 sine 30 over 9.8. Sine 30 is 0.5. That's why you are seeing 0.5 there. 2 times 20 times 0.5 over 9.8, you will have 2.04 seconds. Maximum height, u square sine square theta over 2g. U 19.6 now. Okay, let me not skip that part. Let me write it for you to see. So u square, that is 20 square. 20 square sine square theta is 30, or I can say sine 30, then I will square it. Let me do it that way. Please, students used to make mistake by doing sine 30 square. 30 square is 900. Some students can do sine 900. Whereas that is not what they mean by sine square theta. What they mean is that you find sine theta first and then you square it. Okay, you find sine theta first and then you square it, divided by 2g is 2 times 9.8. Okay, sine 30 is 0.5. When you square 0.5, you are going to have 0.25. So 20 square is 400. 400 times 0.25. So everything divided by 2 times 9.8, that is your 19.6. So you now have 400 times 0.25 is the one that gives you 100. Okay, is the one that gives you 100. So that is the 100 you are looking at here. Since it's objective question, you don't need to waste too much time writing. So as long as you already know what you are supposed to do, you move on. So 400 times 0.25 is the one that gives you 100 over 19.6. You have your 5.1 meters. Then range is u square sine 2 theta over g, which means you multiply your theta times 2 first before you find the sine. 2 times 30 will give you 60. Sine 60 is the one that is 0.8860. Okay, that is 20 square times sine 60 degrees everything divided by 9.8. So which means your range is equal to 400 times 0.8660 over 9.8. Then you have 35.3. Now I want to ask, what if the question had asked that you should calculate the time taken to reach maximum height? Time taken to reach maximum height. What would have been your answer? How would you have solved that question? Time taken to reach maximum height. Who can solve it for us? Time taken to reach maximum height. Anybody? Time taken to reach maximum height. Anybody? Hello, can you hear me? Let me know whether you can even hear me.
So will it be 1?
Are you asking me? Just one? Exactly one?
Yes.
Which formula did you use?
So it's the formula you gave us now.
Tell me the formula now. Tell me the
U
formula.
U sin theta over G.
Okay, good. Remember I said the relationship between time of flight and time taken to reach maximum height is that time of flight is 2 times time taken to reach maximum height. The reason why I asked is because sometimes they can give you time taken to reach maximum height in a question and ask you to calculate the time of flight. Okay, I will give you a question like that now. So you are correct. Your answer will be 1.02, right?
Yes.
Good. That's the
So
answer.
please explain that range again.
Okay. Range is u square sine 2 theta over g. U is 20, so that is 20 square. Sine theta is 30, right? 2 times 30. 2 theta means 2 times 30. That will be 60. That's why it's sine 60. Do you understand that now?
Okay.
Mm-hmm.
Okay, thank you, sir.
All right. So this is the question I was talking about just now. If I can have a question like this, you can have a question like this in an exam. If the time of flight of a projectile, if the time of flight of a projectile is 40 seconds, for instance, 40 seconds, calculate time taken to reach maximum height. If you look at it now, you'll be wondering, how? What are you going to do? But it's very, very simple. The simplest of them all. Who knows the answer already?
Sir?
Who knows the answer to this question?
Sorry. So wait to
Okay, I'm still waiting.
40, yeah.
Okay, well, let me solve. Our time is gone. Our time is gone. Time of flight, I've said it before, that is equal to 2 times time taken to reach maximum height. Time of flight is 2 times time taken to reach maximum height. So, and they said time of flight is 40. 40 is 2 times time taken to reach maximum height. So it means time taken to reach maximum height is equal to 40 over 2. So time taken to reach maximum height is what? 20.
Yeah, I said it.
Okay, very good. Thank you, Joe. It's 20. Because time of flight is double time taken to reach maximum height. Don't forget that. Time of flight is double.
Okay.
So which means time taken to reach maximum height is half the time of flight. Is that okay?
Yes, sir.
All right. Let me give you an assignment. Just one question. Write it down or screenshot it, however. This is a question. Calculate 1 time of flight 2. Time taken to reach maximum height. 3. Maximum height. 4. Range. Are we through? Have you written it or have you screenshot?
Yes.
Okay. Everybody, right? Send in your answers to the Telegram group. Send in your answers to the Telegram group. I want to see it, okay?
I do tomorrow.
Anytime you
Okay,
do it
till next
between
class.
now and tomorrow. Till next class. How many days do you want to use to solve this one question?
No, so I'm busy.
You are busy, I understand. But this question will not take you 5 minutes to solve. You know, right?
It's on fair.
Okay, so between now and tomorrow morning, is it okay?
Yes, sir.
All right. Have a
Okay,
wonderful
sir.
night. Okay. Good night.
Good night, sir.
Yeah, Precious, Adamu, Ella. Who is there? Whose name do I? Who is there that I have not called? Vera. Who else again? Yes. All right. Have a wonderful night. Good night.
Nice, sir.
Okay.
Hello, Precious. Hello. Hello, Precious. Hello, Precious. Has the class ended?